Hi, hello everyone. This is Ameer, your physics educator at Unacademy, and here we are with the second session of our beautiful chapter, Kinetic Theory of Gases, right? So we have completed our first session, and I hope you all came with the revisions, right? And in this second session of Kinetic Theory of Gases, mainly we'll be discussing all the postulates of Kinetic Theory of Gases, okay, and all the kinetic gas equations, which are very important, and we are going to do the derivation also, and we'll be doing so much of numericals. So I hope you all came prepared. So before we start with the session, बच्चा लोग, tell me how are you all doing? कैसे है मेरे बच्चा लोग? Tell me how are you all? Hi Royal, good evening. Anera, Saluni. मेरा दिन तो बहुत बढ़िया जिया. Bhumika, good evening. Miara, wave and oscillation not done. We are going to start after this, right? Sumit, good evening. Jia, okay. A big hi to every one of you. Good evening, Mera Chalu. So I hope you all had an amazing weekend, I suppose, right? So we saw on this Friday. So I hope you all had an amazing weekend, had a very happy moments at the same time, spend enough time for your studies also, right? Anshika, good evening. मैं तो बिल्कुल बढ़िया. Shreya, Royal, okay. A big hi to every one of you and good evening. ठीक है. I know that many of you might be seeing me for the very first time. For them, this is Ameer, your physics educator, and a bit of introduction about myself is given on the screen. Okay, I have an experience of more than 3.5 years in the field of teaching JEE, NEET, and board student. I'm a BTech graduate from NIT Calicut, and that is all about me. For the time being, okay, and obviously we are going to see each other every day. We'll come to know more about each other. Okay. Now moving on, I'll just show you the schedule for this particular week. I forgot to adjust the size here, but I hope you all can see, right? So today we'll be having the second session, and on 3rd Feb, which will be Thursday, we'll be having the next session at 8 p.m., which will be the third session of Kinetic Theory of Gases. And on Friday, हम क्या करने वाले हैं मेरे बच्चा लोग? We all know how important the chapter is thermodynamics, right? We are going to cover the entire concepts of thermodynamics in 1 hour on this Friday at 10 p.m. Don't miss your chance. Okay? Don't miss at all. Moving on. Bacha log, you have so many favorite teachers here in Unacademy, and you don't want to miss any of their live classes, right? So all the updates are given in the Telegram channel. The link for joining the Telegram channel is given here and also in the description box. You can click on it and be a part of the Telegram channel. Okay? Now, what is this Bugs Bounty? It's an amazing program which can help you to get lot much of prizes. What do you have to do? Go to the description. There you'll find a form. Fill the form if you are finding any inappropriate content in the videos uploaded by Unacademy. If it is valid, बहुत सारे prizes मिल जाएगा आप सब लोगों को. चलो, ठीक है? Now, let me ask you: is there anyone here in this classroom who haven't written an Unacademy Combat scholarship test? Let me tell you, you guys are missing a lot much of gifts and benefits from Unacademy, and I don't want any one of you to do that. So jaldi say come and enroll for this combat scholarship test, and if you are one among the first 3 ranks, what are you going to get? Is it some certificates? बिल्कुल नहीं. For the first rank, gold medal मिल जाएगा मेरा अच्छा लोग, and for the second rank, silver, and for the rank 3, bronze medal. Wow! And on top of it, first 3 ranks will be given 1 year of Unacademy plus subscription for free. Others, don't worry, मेरा बच्चा लोग, for a rank of 150, scholarships are being awarded. Okay, so just come and claim all your rights and be a part of Unacademy family. And one more thing, if you want to write this compact scholarship test, ये तो बिल्कुल free है. You don't have to give anything. Okay, you just need to put in the code during the time of registration, which is AMB10. Use this code, be a part of the scholarship test, and win lot much of prizes which is waiting for you. ठीक है? Now, like I asked in all my classes, है ना? जी हाँ बिल्कुल हम शुरू करने वाले हैं, है ना? We have some things to be done. उसके बाद बिल्कुल we are going to start. Now tell me, okay, how many of you have already shared the class to all your friends? Those who haven't, jaldi se kar le. Share the class to all your friends. Here we have Jia, Nancy, Purnima, Shreya, Miara, सुमत भैया के शेयर, राइट, मुस्कान, मथुरिया, बहुत सारे लोग से. So everyone, जल्दी से share the class and tell your all your friends that भैया has started the class. ठीक है, जल्दी से join कर ले, and we are going to discuss all the concepts of kinetic theory of gases. Fine, okay. Now moving on. देख ले. In the meanwhile, we have 2-3 minutes. Okay, in the meanwhile, I just explain all the amazing features of Unacademy Plus subscription. देख ले. But chalo, nowadays we are learning through YouTube, right? It's an amazing thing. It's a very good thing. I also do support that. But okay, there are some things which you are missing, and I want every one of you to know that what all things you're missing if you are not a part of Unacademy Plus subscription platform. Because nowadays, right, or many students would love to have that personal mentoring or personal guidance directly from the educators, right? Whenever they make mistakes, they would love to have an educator to tell that ये तो गलत है. This is not the way to be done. If you want this to happen, you have to be a part of the Plus subscription platform, because in the platform we have what is called as live chat boxes, okay, question tabs where you can upload all your doubts and get it cleared. Still your doubt is not cleared, let's say. Fine, we have a feature called as in-class calling facility. Matlab through the app, through the Unacademy app itself, you can call your educator during the live class, okay, talk to him, get your doubt cleared before you leave the class. Isn't it awesome to study something with zero doubts? Yes, it is. Now, other things are top educators of the country will be there who's having an immense experience in the field of teaching. Because of their experience, obviously, they'll be knowing what will be the strategy for the exam that you have to be prepared for, right? What all questions you must be doing so that you can make the best preparation for all your examination. What happens? You will ace in all the examinations you write and you will be ending up in the colleges, whatever you are dreaming about, isn't it? Yes, of course. Then study materials will be given, practice tests, live test series. Everything is just made here, right, to make you everyone score very better marks for all the examination. Now, if you go for 12 months, it will cost you 1,250 rupees. But right now, if you make the subscription before tomorrow, you will be given before Feb 2, which is tomorrow midnight, you will be given not 10%, 20% of discount. Mera bacha log, you simply have to use a code of AMB10. Whatever was the price I was telling, from that you will be given extra 20% of discount. Usually it was 10%, and this offer ends tomorrow. Don't miss your chance. 20% discount. Wow, it's so amazing. Make it happen. We have one more subscription which we call it as Iconic. Okay, in Iconic, we'll be having all the features of plus some extra features such as personal mentor. Matlab, a person will be there to design and to plan all your academic activities. Matlab, you don't have to think about what you have to study, how many topics you have to cover. For everything, this person will be there. So when this person is assigned, you'll be feeling so free. You just need to come and study. You don't have to worry about any other thing. Right? Then live doubt solving classes will be there. Weekly reports will be given to you. Now, if you go for 12 months, it should cost you 2,333. And as you all know, offer is going on, right? If you make the subscription before tomorrow with the code, what's our code? AMB10, right? And it's not 10%, 20% discount you'll get if you make the subscription before tomorrow midnight. Don't miss your chance, okay? Now, let me tell you, kinetic theory of gases and most important numericals we are going to solve in tomorrow's class. Okay, 2nd Feb, which is 4:30. So don't miss your chance. I want every one of you to come and enroll for this. And for enrolling, the link is given on top of the chat box. Can you all see that? Can you all see the link? Okay, just click on that link and you can be a part of the special class which happens on Unacademy app. It's completely free. You don't have to think that this is happening in the app and we have to pay something. You just need to use the code of AMB10. You can get enrolled for the special class completely for free. Okay, so tell me, are you all ready for the session to get started? This is the second session of Kinetic Theory of Gases. It happens at 8 p.m. Abhijit. Yes, quickly, we're going to start the classes, but right now I just want the permission from every one of you. I want everyone to give me that thumbs up and tell me that, sir, just start the class. We are super ready. Hi, Mahagna, Mehnaz, Pardeep. Yes? Miara, let's crack it. Jia, Abhijit. Okay, Saloni, everyone is like, sir, just start. We are with you. Now, this is, as I already have mentioned, this is our second lecture. Right? So obviously, we must have covered some topics in the first lecture. Tell me what we have covered. Yes, we have covered all the gas laws that was existing with the ideal gases before the invention or before the discovery of the kinetic theory of gases, right? And which all were the laws that we have learned. But look, tell me one by one. We have learned Boyle's law, right? These are what we have learned in the last class. I'll write it. Okay, those who missed, please to watch the session one, last class. We have learned Boyle's law, right? Then we have learned Charles' law, right? Uske baad we have learned Avogadro's law. Yes or no? Yes, we have learned. And after Avogadro's law, we have seen the ideal gas equation. I think you already know about all these laws and formulas from your numerical classes and from your chemistry classes, right? We have learned in detail about this. More than that, all these laws will be applied to ideal gases only all the time, we have learned, right? And this gas laws can be applied to real gases only in certain conditions. Which was those certain conditions where we can apply all these gas laws? Yes, it is at very high temperature. We have learned, right? At very high temperature and choto wala pressure, at low pressure, right? All the real gases will be acting like ideal gases, and in those cases, all the real gases will be obeying these gas laws. Was it till here we have completed our classes, right? Yes. Now, tell me, what are we going to learn in today's classes? In today's class, we are going to do all the postulates of kinetic theory of gases. Postulates of kinetic theory of gases is what we are going to do. Then we will do the kinetic gas equation. First we will see which are the kinetic gas equation, okay? And then we will be making the derivation for that, and obviously at the end, what is it? We are going to learn many numericals. This is the flow of this particular chapter is going to be, or in this particular session is going to be. Let's get started, right? Okay. As I have already told you, we are going to start with the postulates of the kinetic theory of gases. I hope you do remember, Anna. We have told in the first class what was this kinetic theory of gases. Kinetic theory of gases actually tells that, right, the atoms with which all the matter is being made up of is continuously moving, which means it is associated with a speed or a kinetic energy, and it is this kinetic energy or speed is responsible for all the properties of gases. Matlab, let's say pressure, let's say volume. All these properties can be explained with the help of kinetic energies or speed, and this is what is actually told in the kinetic theory of gases. So first we'll go with the postulates of kinetic theory of gases one by one. You can also note it along with me, and after discussing all the postulates, if you have any doubts, please do ask me. Okay, badhiya chalo. Okay, everyone go with the first postulate which everybody might be knowing. Okay, you can learn first and second postulate as together. It's actually the first postulate only, though it is being written as two different postulates. What is it? Like everybody, gases are made up of small particles called as atoms or molecules, which we know, which we already know. And molecules of the same gas are identical in all aspect. Matlab, you are taking a beaker, right? Here you have hydrogen molecules. You are taking another beaker. Here you have hydrogen molecules, right? What is actually said in the second postulate is that if you take the hydrogen molecule from this beaker and from this beaker, it will be exactly looking like the same, which we already know, right? It will always be H2, which will be having the same mass, same shape, same size, same property. Everything is going to be the same, right? This is the first postulates of kinetic theory of gases, which we already know, so I'm not going in deep with it. Now, the next one is very important. What is it? Molecules are in constant random motion along the straight lines. But chalo, we are talking about gases, right? Where molecules are very free to move. So the third postulate tells that if you are having a gas molecule, let's consider this particular dot as a gas molecule, it will be random motion. वो तो इधर जा सकता है, ऊपर जा सकता है, left side जा सकता है. It can be having a random motion, but this random motion will be happening in a straight line. It will be always traveling in a straight line. This is very important. Okay, it will not be making a zigzag motion like this. It won't be making a projectile motion or a parabolic motion or a hyperbolic motion. Whenever the gas molecules are moving, the third postulate tells that it will be moving in a straight line. Very important. Okay, now let us make a Chotu derivation from here, which is required while we derive the kinetic gas equation. What is it? Let's say this gas molecule is moving with a velocity of u. When it is moving, it will be moving in our three-dimensional spaces. We can obviously resolve its velocities. Right? There will be velocity of u in the x direction. We mark it as ux. There will be component of u in the y direction, which I am marking it as uy, isn't it? And there will be component of u in the z direction. We can mark it as uz. Okay. So tell me, how can you express u, the vector u, in terms of its components? We all have learned vectors, isn't it? How can we express? That is equal to, kaise? Ux I cap plus uy j cap plus uz k cap, isn't it? We all have learned this, right? Not a big deal. One more thing. The third postulate of kinetic theory of gases adds one more thing. Okay. It tells that the particles are having equal probability to move in all the direction. Matlab, it is having equal probability for the particle to move in the x direction, y direction, and the z directions are equal. And from that, what we can assume, as a particle is having equal probability to go along x, y, and z direction, we can say that its component in the x, its component in the y, and its component in the z will be equal. This is very important. Okay, this is very important. Okay, you can all write it down. It says, the kinetic theory of gases says it has equal probability to move in all directions. And that is the reason why we have written ux is equal to uy is equal to uz. Fine. Okay. Now one more thing, a Chotu we can do here. Vector u is ux I cap plus uy j cap plus uz k cap. है ना बच्चों? ठीक है. How can we write the magnitude of u? That is equal to root of its component square, that is ux square plus uy square plus uz square. From the Chotu concepts from vectors, isn't it? And we have written one more thing, that ux, uy and uz are equal. So for uy I am going to substitute it as ux. For uz also I am going to substitute it as ux. Tell me what will be there inside the root? That will be 3 times ux square. समझ में आ गया? uy is equal to, I have substituted as ux, uz भी ux है. So this will be ux square plus ux square plus ux square, 3 times ux square, that is u. Square कर ले, u square is equal to 3 times ux square. Okay, this will not be much helpful for the time being, but this is going to be super helpful once we make the derivation for kinetic gas equation, which we are going to do it in 15 to 20 seconds. So keep it in your mind. The square of its total velocity is equal to 3 times the square of any of its component. Either 3 times ux square, can I substitute it with uy square also? Yeah, because ux, uy and uz are equal. Okay, so idhar tak samajh gaya? We have discussed the first 3 postulates of kinetic theory of gases. aa raha hai samajh? Miara, Anaira, Shreya, Jia, Royal, Anisha, jaldi bol de, and jaldi note bhi kar le everyone. We are supposed to use white background when we teach from laptops. Okay, so are you able to follow me properly while though I am teaching through laptops? Is it fine? Or are you having trouble because right now I am in Bangalore, I don't have my smart board here. Is it fine? Are you able to follow everything, whatever is being taught here? Royal noted, Sumit noted, Muskan note kiya? Okay, yes, done. Jia yes, Miara yes, Nancy, sab badhiya hai na? So I hope everything is fine. Completely fine? Yes, bahut badhiya, theek hai. Okay, so we'll proceed, right? So I hope all the three postulates are super clear to every one of you. So we're going to proceed further. देख ले, we'll go with the fourth postulate. What does it say? All collisions of gas molecules among the molecules and the walls of the container are elastic in nature. Only during the third postulate we have discussed molecules are in random motion, right? Constant random motion. So obviously when the molecules are moving ऐसे देख ले, one of the molecule is moving in this direction, let's say the other molecule is coming in the opposite direction. Won't they be colliding each other? Yes, they will be colliding. At the same time, consider this gas molecules in a container, right? These molecules are moving, and during its motion, won't it be colliding with the walls of the container? Yes, it is going to be. Now, what is said in the fourth postulate is that during the collision, right, this collision is completely elastic in nature. These collisions are elastic collisions in nature. How many of you do remember what was elastic collisions? We have completed from work energy power, right? That chapter we have completed what is elastic collisions. Yes, those collisions where the momentum, right? We'll write it as momentum instead of using. It's simple. Momentum is conserved, right? And at the same time, the kinetic energy or the energy is also conserved, right? The energy is not lost from the system. Kinetic energy will also be conserved, right? Such kind of collisions we call it as elastic collision. Okay, so whatever collisions happens here, right, when the molecules are moving, right, all those collisions are what? Elastic collision. Momentum is conserved, kinetic energy is also conserved. Okay, ठीक है? Fine. Now let's see what is there in the fifth. The pressure of a gas is due to the collision of gas on the walls of the container. We were continuously learning till now, right? Pressure of a gas, pressure of a gas, pressure of a gas. And the fifth postulate actually tell you how the pressure of a gas is originated, right? What is the reason for the pressure of a gas to be? What does it say? Pressure of a gas is due to the collision of gas on the walls of the container. I'll explain. Everybody listen here. Very important concept and postulate here. This is our container, and let's say this container has so many molecules. I'm taking one of the molecule here. Okay. Let's say this molecule is moving towards a wall with a velocity of ux. What will happen? It will go and collide with the walls, and as the collision is completely elastic, it will be bouncing back with the same speed in the opposite direction. Matlab, to the molecule there happened a change in momentum. And if there is a change in momentum, what happens? There will be a force. And if there is a force, that force per unit area is what? Pressure. So during the collision, when the gas molecules are colliding with the walls, right? Because of the change in momentum, there happens a force and there happens a pressure. And the pressure of the gas molecule is completely because of these collisions particles make with the walls of the container. Is it clear? Is it clear? I will write it down once again. Pressure of gas molecules are actually because of collisions of gas molecules on the walls of the container. On the walls of the container. How? Because the collision is producing a change in momentum. Okay, change in momentum is producing a force, and that force per unit area is actually acting as hamara pressure. Clear? This is very important. Don't leave it at all, I say. Okay? So hold on to it. This is a very beautiful concept. हाँ क्या समझ? First 5 postulates are being completed and we have discussed in detail. Note कर रहे हैं ना सबने? I'm giving you time enough to note also. Sumit noted Jia. Okay, clear, crystal clear. Voice is not clear. कैसे? अरे स्पीकर का वॉइस बढ़ाओ. ठीक है अभिजीत, स्पीकर का वॉइस बढ़ाओ. मेरा वॉइस अच्छे से आ रहा है ना? कितना अच्छा वॉइस है मेरा. Everyone will be like, sir, you are self-praising कर रहे हैं आप. Okay, now moving forward, the sixth postulate क्या बोल रहा है? Sixth postulate क्या बोल रहा है? देखिए, the kinetic energy of the gas. Gas molecules are moving. It will be associated with a speed. When there is a speed, those gas molecules will be associated with a kinetic energy. Sixth postulate says that those kinetic energy of a gas depends only on the absolute temperature. The kinetic energy of the gas molecule depends only on the absolute temperature. Matlab, even though there are two different types of gas, let's say we have an hydrogen gas in a container and we have oxygen gas in a container. ठीक है? These are two different types of gases. Even though there are two different types of gases, if they are having the same temperature, what does sixth postulate of kinetic theory says? Sixth postulate tell that both of them will be having the same kinetic energy. I'll just draw the figure. Then you will understand. Okay, here we have hydrogen gas molecules, ऐसे. Here we have oxygen gas molecules, ऐसे. Both these molecules are moving, and if both of them are at the same temperature, right? The sixth postulate says kinetic energy of each of these molecules will be the same, because kinetic energy of each and every molecule depends only on the temperature T here. It is irrespective of which gas it is. And we can easily imagine this. We are giving heat energy and increasing the temperature of any body. And what will happen if the temperature is increased? Particles will start moving faster and its kinetic energy increases. So obviously, we can easily make the equation kinetic energy of the molecule directly proportional to temperature. Temperature बढ़ गया, molecule will start moving faster, kinetic energy obviously will be increasing, right? है या नहीं? You do all agree with me, right? Yes. And this is our sixth postulate. Got it? Okay, sixth postulate समझ में आ गया? This is the picture here, and this is our postulate, sixth postulate here. Okay, now till the sixth postulate of kinetic theory of gases है हमारा. चलो, this is being applied and obeyed both the real gases and the ideal gas. Okay, real gas and ideal gas obeys all the above postulate. Okay, real and ideal gas obeys, but the seventh, eighth and ninth are mainly focusing on the seventh postulate and the eighth postulate, that is only obeyed by ideal gases, and that is obeyed by real gases only in certain conditions. Which are those conditions? We already know, we have discussed yesterday. When real gases acts like an ideal gas, what, in which case, what condition? At higher temperature and at lower pressure, real gases will be acting as ideal. In only those cases, the seventh postulate and eighth postulate will be obeyed by real gases. नहीं तो seventh and eighth postulate is obeyed only by the ideal gases, or it is only applicable to the ideal gases. ठीक है? Okay, everybody is giving the answer here. Abhijit, yes, high temperature. Very good. High temperature. Vani, Mithilesh, बहुत बढ़िया. You guys are the best. Okay, ठीक है. So चलो, coming back. Let's start reading the seventh postulate. What said there? अरे volume occupied by gas molecule is negligible when compared to the total volume of the gas. I'll explain. This is very important. ठीक है? Seventh postulate. You take a container. Okay, and in this container you are filling the gas. So obviously these gas molecules will be spreaded throughout this container of volume V. So whatever is the volume of the container, same will be the volume of the gas. है ना? So volume of the gas will be equal to volume of the container. That is volume of the gas actually. Whatever is the volume of the container, वो होता है volume of the gas. What is volume of the gas molecules? Because that is being defined in our seventh postulate, right? All these molecules that you see in this container, you are clinging it together. You are taking all those molecules into a very small space. I am taking all those molecules of the gas into a corner of this particular container. This volume occupied, can you see? This volume occupied by those gas molecules. That is actually the volume of the molecules, volume of the entire gas molecules. And the seventh postulate tells that the volume occupied by this gas molecule, VM है ना, बहुत छोटू है, क्या है? बहुत छोटे है. Volume of the gas molecule is very, 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 very small compared to the total volume of the gas. Which means that we can actually neglect, right, the volume occupied by this gas molecules. Or this also says that we can consider the volume of this gas molecule approximately to 0. Which means the molecules of gases are not even occupying the spaces. That's what the seventh postulate is telling. But we know that this is not true, right? The gas molecules do occupy some space and it has some volume. And that's why I said the seventh postulate is only applicable to the ideal gases. Matlab we have to imagine in this way so that we can make the derivations what we are going to do later. And this will be applicable to the real gases in only certain conditions. High temperature and low pressure. ये तो समझ में आ गया? आ गया ये समझ, ये तो बहुत बढ़िया है. Fine? Clear? Seventh, this is only applicable purely to ideal gases and it is applicable to real gases in certain conditions. ठीक है? मुस्कान, मंदिरा, रोयल, जिया, वाणी, श्रेया, प्यूजा, you guys are noting है ना? मैं तो ऐसे बोल रहा हूँ. आप guys, you guys are noting, right? Yes sir, clear. रतु, रोयल, समझ आ गया? अरे वाह, बिल्कुल बढ़िया मेरे बच्चों लोग, बिल्कुल बढ़िया. ओके, बाकी क्या है? अरे 8th postulate तो बाकी है, देख ले. There is no intermolecular force of attraction among molecules. अरे बाप रे, ये कैसे हो गया? देख ले. We know that if we take any two molecules from any matter, one molecule will be attracting the other. Matlab there will be intermolecular forces of attractions, right? This is what we have learned from our childhood, or let's say from our 9th standard, 10th standard classes, right? So the 8th postulate is telling you whatever you have learned till now, bhul ja, and now we are telling you something, just believe that. And what does it say? Here it says that the 8th postulate of kinetic theory of gases tells that there doesn't exist the force of attraction between the molecules, or we are asked to assume that there is no force of attraction between the gas molecules. We know that in gases, gas molecules are very far apart, right? The force is very less, right? We know that the force of attraction is very less here, but the postulate tells that we have to consider, or we are going to approximate that the force of attraction is almost 0, or there is no force of attraction between the gas molecules. Is it clear? Right? We know that this is not applicable to real gases, right? This is only applicable to our ideal gases, or only in our imagination, or only in certain conditions. Okay? Okay? Is it clear? Clear है ना? And last, हो गई बात हमारी. Last 9 postulate क्या बोल रहा है? Okay? वो क्या बोल रहा है? Gravity is neglected. 9 postulate tells that, right, हमारा molecules of gases है ना, molecules of gases are very small, बहुत tiny है and बहुत हल्का भी है. It says the molecules are very lightweight. Okay, matlab the mass is very small, so that the weight mg, which is given by the Earth gravitational force, can almost be neglected there. Okay, and this is what is said in the last postulate of kinetic theory of gases. Okay, I'll give you an example for that. When we have a ball, let's say I'm throwing this ball in the horizontal direction. Is it going to continue its motion in the horizontal direction? No. You know that it will be making a projectile motion like this. Why is it coming down? Because the earth is attracting it in the downward direction. खींच रहा है, नीचे खींच रहा है, right? The weight mg. But in our case, if you are having a gas molecule, if it is moving in the horizontal direction with a velocity u, it will be continuing its straight line motion. It will be continuing its straight line motion. Why? Because it is said in our postulate that the molecules are so lightweight, so the weight acting on it mg can approximately consider as 0. So if nothing is holding it, or if nothing is pulling it in the downward direction, can't it move in a straight line? Yes or no? Yes. And that's what exactly we have learned in the third postulate, that the molecules are always moving in a straight line before two collisions. Okay, and actually that is a resultant of, that third postulate is actually the result of our ninth postulate, which tells gravity is not there. As gravity is not there, or as gravity is approximated to 0 or neglected, right, there is no downward force, and that's the reason the particles are moving in a straight line. Okay, everyone, बहुत 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 अच्छे से I try to explain, बोल दे, समझ में आ गया? तन्मय, पूजा, राज, जिया, आशीष। सर कोई गैस पूरी आइडियल तो नहीं होती है, ये लॉस अप्लाई क्यों करती? अरे आशीष, right, real gases almost behave like ideal gases in certain situations. So in those situations, can't we study the behavior of gases? Yes, we can. And that's what we do here. Clear and understood, Shreya, Mansi, Bhumika, Roel? ठीक है. Now, don't think that we're going to start doing the numericals here, because this was just a theoretical postulates of kinetic theory. Questions so kuch nahi hai. And right now, we are going to make another derivation. Ready for that? Fantastic, Royal, Tanmay, Bhumika, yes? Okay. Which topic is going on? Kinetic theory of gases. Okay. For doing the numericals, we have to learn this particular concept also. Which concept? Right now, we are going to see the kinetic, we know ideal gas equations, right? So there are certain equations which are being derived from the postulates of kinetic theory of gases. We call it as kinetic gas equations, and this is what we are going to learn right now. Very, 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 I don't know how many times I can write very, and it is very important. Okay, so it is going to be super important, mera bachcha lo. So I don't want any one of you even to think about anything. Okay, kuch bhi, whatever happens outside, okay, just close your eyes and listen. If you can listen to this concept for the next 10 to 15 minutes, I can make sure that the formula, okay, and the entire concept is going to be super clear to every one of you. Okay, I hope everybody of you can promise me that, right? Let's say Tanisha, Mithilesh, Lucifer, ठीक है, Anayara, Jia, Miara, ठीक है, देख ले. First, I'll tell you what is that equation, right? And then we will make the derivations. देख ले. P is equal to 1 by 3 nm square. Let's say here we have a container with so much of gas molecules. The kinetic gas equation says pressure of the gas P, okay, into the volume occupied by this gas molecule is equal to 1 by 3 times m. What is m? Mass of one single molecule. Okay, m means mass of one single molecule of gas, whatever we are considering, that is shown to m. ये n क्या होता है? This is very important. You should be knowing now what are the terms corresponding to. Only you can solve the numerical. N corresponds to total number of molecules, right? Okay. Now, if you refer to your NCERT, you will find this equation in a different way. What is that different way we are talking? Here it is P is equal to 1 by 3 mn Vrms square. What is Vrms? I'm explaining. Don't worry about that. Right? In your NCERT, if you refer, you will find the equation as PV equal to 1 by 3 m. You are going to divide n with volume, multiply this n with volume, and Vrms square. This V is volume. Okay? We'll keep it capital. Bada. Okay. Now this become 1 by 3 m. What is total number of molecules divided by volume? Number of molecules per unit volume, right? So we'll be expressing it as Cho2n. Okay, this is capital V volume into V RMS square. Okay, all the equations are one and the same from here, and there small changes are being made. That's all. Okay, so I have written the formula as PV equal to 1 by 3 M capital and V RMS square. Okay, by multiplying capital V RMS square, not a big deal. Okay, anything is fine. Okay, इधर तक clear है ना? We have written everything. Total number of molecules and ये क्या है? V RMS square. V RMS square is root RMS, that is root mean square velocity. Okay, V square or V RMS square means V RMS, root mean square velocity. I know that many of you don't know ये क्यों है. Okay, or ये क्या है? What is a V RMS square or what is the root mean square velocity, right? So everybody listen to me. ये क्या है? What is root mean square velocity? Everybody listen. I'm taking a container. Okay, in this container particles are moving in so many random directions with so many velocities. This particle is having V1, other particle is having V2, next particle is having V3, दूसरा particle is having V5. So n particles are there and the n particle is having velocity of V, right? So V RMS is defined as V1 square, V2 square, V3 square plus till Vn square. मतलब we square all the velocities and add it, the whole divided by total number of molecules, that is capital N, take a root of it, and this is V RMS. What is V RMS? Root of, can you see the root here? Yes. Mean of, dividing it by the total number of molecules of squared value. Root of mean of squared value. We are squaring all the velocities and adding it up, and that is V RMS. Okay, root of mean of squared value. Array, this is just another way of finding the velocity, matlab average velocity, that's it. Okay, it is not something new that is being popped up here. ऐसे कुछ नहीं है. This is same like finding an average. वही है. But you will be asking, so why don't we find out the usual average? Array, the usual average have this problem. Okay, sign का problem होता है. I'll tell you. The particle is there. Right? मतलब in a container there are two gas molecules. One gas molecule is having a V towards right, and another gas molecule is having the same V towards left. As it is towards left, velocity will be minus V. Okay. Tell me what is the average velocity. Okay, V plus minus V, the whole divided by 2. This is how you find out the average, right? Matlab plus V and minus V will get cancelled and it will become 0, and average velocity is 0 there. So in order to avoid this situations, we are squaring the value. If we square the value, this becomes V square. Minus V, even if you square, that will become V square. So this cancellation situations can be avoided while you find out this kind of averages. And that's the reason we are finding out RMS value of averaging. Okay? So we are squaring it and then we are taking the root also. That square effect is gone there. आ गया समझ? Okay, so this is one of the formula that we are going to derive here. Okay, that PV is equal to 1 by 3 mn V RMS square. I hope you got what is V RMS. And second thing is, we will also find out that the kinetic energy for 1 mole of molecules will be equal to 3 by 2 RT. This is also something we are going to derive right now. What all we are going to derive? PV is equal to 1 by 3 capital M Cho2m V RMS square. Then we will from that we will use the above information, and then we will find out the kinetic energy of 1 mole of molecules will be equal to 3 by 2 RT. ये भी करेगा. Okay, and I also have explained ये RMS velocity क्या है. Okay. So your voice is not clear. Isn't my voice clear मेरे बच्चा लोग? Tell me. आप ही बता दे. Okay, do watch the recordings. Okay, Mansi, yes. Is there any voice ka issue? Hello? Okay, do watch the recordings. Okay, Mansi, yes. Is there any voice ka issue? अरे हो गया तो हो गया बच्चा लोग, समझ में आ गया अभी तक? क्लियर है ना? अरे सब बोल रहा है मेरा वॉइस तो क्लियर है. Why some people are only having the issue with my voice? क्यों? हाँ? क्यों 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 क्यों? हाँ, now students are like sir आपका वॉइस तो अच्छा नहीं लग रहा है, थोड़ा है ना गड़बड़ है. So you don't like my voice आजकल, right? Sir, have you come in the mood teaching only today? अरे बाप रे, मैं तो टीचर का काम कर रहा हूँ. I know that I used to track some jokes even though if it was lame है ना. आजकल आज तो है ना बहुत सारा concept तो I just wanted to teach you, so I thought ऐसे I was just going along with the flow. I think we'll take one more lecture for completing this. अरे sing a song. Am I a performer here? So, बच्चा लोग, shall we complete? मतलब shall we proceed? Shall we proceed? What we are going to proceed with? With the derivation. We are used with lame jokes. So you guys agreed that वो तो lame joke है. अरे कितना बुरा लोग है ना आप लोग, है ना? टीचर का जोक्स बोल रहे हैं lame jokes है. ओके, भगवान तो माफ नहीं दे दूंगा आप लोगों को. पता है ना, माता पिता गुरु देव. ओके फाइन. अब मेरा वीडियो का प्रॉब्लम हो रहा है. ठीक है, मैं तो जा रहा हूँ. ठीक है. अरे everybody come back. We'll proceed, right? So first we are going to derive the formula that PV is equal to 1 by 3 m capital N V RMS square, right? For that, what I want every one of you to do is take a cube here. बच्चा लोग, everyone take a cube. सर कहाँ से लाऊं मैं क्यूब? अच्छा क्यूब ले लिया everyone. क्यूब ले लिया. सर आपका क्यूब तो क्यूब जैसा ही नहीं लग रहा है. अरे ओके, कोशिश करके ट्राई कर ले टू इमेजिन दैट इट्स क्यूब. ओके ओके, बहुत अच्छा हो जाएगा. नाउ क्यूब तो बना दिया, और क्या चाहिए? We need the axes, right? We have the y axis here, we have the x axis here, and हमारा पास z axis भी है. Okay. Now we know that the above equation is what we're going to derive, and it's an equation with the pressure actually, right? So let's find out the pressure. We already know how the pressure is produced by the collision of the gas molecules onto the walls of the container, right? So for calculating the pressure produced by one single molecule, I'm going to consider that one single molecule. From there we'll consider we'll find out the total pressure produced by all the molecules. Okay? So as a starting, we are going to take one single molecule here. Let's say it is having a velocity of u1, and we already know we can convert into its component, right? ux1, let's say its velocity in the x direction, uy1 its velocity in the y direction, and uz1 its velocity in the z direction. Okay, what we want to find out? Pressure. What was pressure actually? Collision of these gas molecules. Now for finding out pressure, we are going to consider a collision on the walls. Now that wall, let me consider this. Can you see this wall here of the container? This wall of the container is what we are going to consider for calculating the pressure or to find out the equation of pressure. ठीक है? So देख ले, I'm going to draw that wall of the container separately. ठीक है? Can you all see that wall? Okay. Now towards this wall, this single molecule is moving with its component of velocity ux1, right? Yes, it moves towards the wall, collide with the wall, and it will be bouncing back with a speed. Is the speed going to be the same? Is the speed going to be the same? अच्छा लोग बोल रहे हैं. अरे हाँ, obviously speed is going to be the same. क्यों? क्यों same होना चाहिए? अरे the collision is completely elastic in nature, right? Isn't the collision elastic in nature? Bilkul. As the collision is elastic, it will be coming back with the same speed of ux1 but in the opposite direction. Sir, why you have only considered the speed in x direction? What about the speed in y direction, z direction? Are they being naughty that we are not considering those velocities? Is that the case? देख ले मेरा lame joke तो आ गया. Is that the case why we are not considering the velocities in the y and z direction? बिल्कुल नहीं. देख ले, this wall is parallel to the yz plane. मतलब this wall can only give the force perpendicular to it or in the x direction. So if the wall is giving the force in the x direction, the velocity in that direction will only be changing, and there will be change in momentum only in the x direction, and that change in momentum can only produce force, and that force can only produce the pressure there. Okay, as the force is only in the x direction, velocity in the y and z direction is not going to change. If it is not changing, there is no change in momentum and no force and no pressure. So there is no point of considering velocities in y and z direction for calculating the pressure. ठीक है, आ गया समझ? ओके, इधर तक आ गया ना सबको? अरे बच्चा लोग जल्दी बोल दे, आ गया है क्या समझ? बोले हंसकर, हाँ सर अच्छे से. ओके, बढ़िया से समझ आ गया without having any doubts. ओके जिया, यस बिल्कुल क्लियर. प्रदीप, रुक्षा, रोयल. ओके, देख ले हम कंटिन्यू कर रहे हैं. ठीक है, हम कंटिन्यू कर रहे हैं. नाउ फर्स्ट फॉर फाइंडिंग आउट द फोर्स एंड प्रेशर वी नीड टू फाइंड आउट द चेंज इन मोमेंटम, है ना? और क्या? व्हाट इज द इनिशियल मोमेंटम p1? टेल मी. It let's say the particle is having a mass of m, so initial momentum is m u x1. What is the final momentum p2 after the collision? That is m u x2 but in the opposite direction with a negative sign, है ना? So what is the change in momentum? Delta p क्या होता है? अरे p2 minus p1, that is minus mu x2 minus, sorry mu x2 नहीं x1 ही है. ठीक है, don't get it wrong, x1 ही है because it is coming back with the same velocity, है ना? ठीक है. So final momentum minus mu x1 minus mu x1, minus of minus, it will get added up, this will be minus 2mu x1. अरे change in momentum है, वो तो मिल गया. लेकिन सर, this is a change in momentum of gas molecules. If we get time only, we get the force. Because if we get the force only, we can find out the pressure, है ना? और क्या? So how to find out the time? Time कितना है? देख ले everybody, how to find the time? After it collides from the wall, right? This molecule, after it collides from the wall, this molecule will be moving in the left direction. I'll come back with the red color itself. देख ले, it'll be, अरे red color messed up हो जाएगा बहुत सारा, है ना? We will use blue color. ठीक है, देख ले. After colliding from the wall, this will be moving towards the other wall with a speed of ux1, right? ऐसे जाएगा, it will collide again, and after collision it will be bouncing back with the same speed, and then it will be coming back to the same wall. मतलब after one collision with the wall, it has to travel back to the other wall, and then it has to come back. How much distance it is covering? Let's say this cube is having a length of a. So when it moves backward like this, it covers a distance of a. Okay, when it moves towards the wall again, it will be covering the same distance of a. So the total distance it covers is 2a before it comes to the next collision. ठीक है, distance तो मिल गया sir. Okay, time तो कैसे मिलेगा? अरे time is equal to distance divided by speed. What is the speed with which it travels? ux1. Okay, so time भी मिल गया, change in momentum भी मिल गया. किसको इंतजार कर रहा है? Let's find out the force. Time for force, change in momentum divided by time, that is equal to, change in momentum कितना? Minus 2mu x1 whole divided by time कितना? 2a by ux1, it will go to the numerator, this will become squared. मतलब हमको final amount of force given मिल गया, that is minus 2mu x1 square by a. This is the force on what? On gas molecule, right? This is a force experienced on gas molecule with a negative sign. We know that for every action there is an equal and opposite reaction. If the wall is giving a force of minus 2mu x1 square by 2a on the molecule, won't the molecules be giving an equal and an opposite force on the walls? Yes. So if you write the force without the negative sign, that will be the force on what? Force on the walls by the gas molecules. So you can take the next page and write force F inside the bracket on walls of the container, just opposite to the gas molecules, मतलब वो negative sign तो हट जाएगा, opposite to it. So if the negative sign is gone, what is remaining? mu x1 square by a. अरे बाप रे, बहुत सारा किया ना, बहुत सारा सर, बहुत सारा डेरिवेशन किया अभी तक, थोड़ा और बाकी है, थोड़ा और नन्ना मुन्ना सा. अरे इतना जल्दी हो गया मंदिरा. ओके, इधर तक नोट कर ले and just go through all the derivation that we have did till now, and if you have any doubts बोल दे. श्रेया, जिया, म्यारा, have you all noted? जल्दी बोल दे. हाँ सर, बिल्कुल नोट किया. समझ में आ रहा है ना सब? We're gonna proceed. Okay, so इधर तक नोट किया. We got the force experienced by the walls, on the walls, by one single molecule, है ना? Because we have considered only one single molecule, and this is a force given by one single molecule on the walls. Now, I want to use one single derivations we have done previously. I told you at that time, we'll be using it later, that u square is equal to 3 times ux square, or ux square is equal to 1 by 3 times u square. We have did this derivations. Okay? So this derived value, we are going to use it here. Okay? ux1 square is equal to x1 square is equal to 1 by 3 times u1 square. This is very important, and right now we are going to substitute this. Take le. Everybody take le. Mass by A, ux1 square is equal to 1 by 3 times u1 square. होगी बात. Okay, and this is the force on the wall by one single molecule. And we are going to calculate the pressure, total pressure on the walls. We know that it is not one single molecule, right? So let's say that there are n number of molecules. Total number of molecules is capital N. Okay, and this is the force produced by one single molecule. So if you want to find out total pressure, we want to find out the force produced by total number of molecules. कैसे? F total will be equal to 1 by 3 m by a u1 square. This is a force produced by the first particle, plus 1 by 3 m by a u2 square. This is a force produced by second. Then we will add a third, fourth, fifth till n number of particle. 1 by 3 m by a un square. Clear है इधर तक? ठीक है? So whatever you see as common, take it outside. 1 by 3 m by a inside the bracket u1 square plus u2 square plus un square. Isn't this what we have? Yes. Now, in order to introduce Rms velocity constant, I'm going to divide this by capital N and multiply this by capital N. हमारा काम तो हो गया मेरा, चलो हो गया, almost done. We are done almost. देख ले, capital N, u1, u2, u3, un square. Does this bring any memories? I'll take it to you those memories. देख ले, Vrms is equal to v1 square plus v2 square, v3 square, vn square by n. So if you square Vrms, this will be equal to v1 square plus v2 square plus v3 square till vn square, the whole divided by n. मतलब v1 square plus v2 square plus v3 square till vn square by n is Vrms square. ठीक है? अरे same thing I'm going to substitute here. U1 square, U2 square, U3 square till UN square, the whole divided by N is U RMS the whole square. Okay, equal to what is remaining? 1 by 3 M, this capital N by A into U RMS square. Yeah, we are almost at the end of the derivation. So this is the total force. Done? इधर तक write down everyone. 10 seconds is all yours. Okay, इस derivation के बाद हम बहुत सारे न्यूमेरिकल्स करने जा रहे हैं मेरे बच्चा लोग. So जल्दी से जल्दी फटाफट नोट कर ले नोट कर ले. So how much are you enjoying this conceptual class? बहुत सारा concept हो गया ना आज. बोल ले कितना enjoy कर रहे हैं आप लोग हमारा conceptual class. Done? Note किया सबने? ठीक है. Note it. We'll check PDF. Eyes will pain if I see. ठीक है. हम तो जा रहे हैं. Now I'm going to write the same formula once again in the page here. Force F is equal to 1 by 3 small m n V RMS square or U RMS square by A. And we want pressure. Right? Pressure is equal to force divided by area. Force is 1 by 3 M capital N V RMS square the whole divided by A. है ना? So force is this divided by area. Area कितना है? अरे we were considering this wall here. ये wall and this is one single wall of this cube with the side A. So this cube side का area कितना है? A into A square. ठीक है? No doubts, right? ठीक है. So area I'm going to substitute it as A square. What does it become? Pressure P is equal to 1 by 3 M N V RMS square. The whole divided by A square into A is A cube. Cube of A is actually the volume. Now rearrange, cross multiply. PV is equal to 1 by 3 chotu M capital N V RMS square. Did we derive it? Did we derive it, मेरा बच्चा लोग? Have we finally derived the formula like I have promised you? Is the derivation done? Everyone just yell out बच्चा लोग. हाँ sir, बिल्कुल हम तो कर दिया. Finally हम तो कर दिया. Isn't it? देख ले. We have gone step by step by explaining all the concepts in detail. Now, even if you try after the class doing this derivation by yourself, ऐसे करेगा आप लोग. Okay? Done. Right? Okay, that's my बच्चा लोग. Okay. इधर से नन्नू मुन्ना और concept भी है. That also we'll do. Kinetic energy का एक formula है ना? Shall we do this? Shall we do that? Kinetic energy का भी देख ले. So we'll keep this formula here itself. That PV is equal to this. Now we are going to find out the kinetic energy of the entire gas molecules here. देख ले. We know that so many particles are there with speed v1, speed v2, speed v3. N number of particles are there and their speeds are v1, v2, v3, v4 till vn. So their total kinetic energy will be equal to कितना हो जाएगा बता. We'll find out the kinetic energy of the first particle half mv1 square plus we'll find out the kinetic energy of second particle add करेगा third, fourth, fifth, sixth, seventh till nth particle we will find out the velocities half m vn square. Common क्या है? What is common here? अरे m by 2 common है, half m we take it as common. Inside the bracket we have v1 square plus v2 square plus v3 square till vn square. बाप रे हो गया. Now like we did in the previous case, dividing by capital N, multiplying by capital N. What is v1 square, v2 square, v3 square, vn square by n? Do you remember? u1 square, u2 square, u3, un square by n is u RMS square. v1 square plus v2 square, v3, vn square by n is v RMS square. So this formula will be half m capital N v RMS square. Clear? अरे हो गया. अरे 2 more minutes. Is it done till here? The total kinetic energy is half mn Vrms square. Tell me, have you seen this before? Have you seen this before? हाँ, mn/v/rms square. Have you seen this? देख ले. और क्या सर, हम तो दिखाया इन द प्रीवियस इक्वेशन. देख ले, देख ले. हाँ सर, अब देख लिया सर, अच्छे से देख ले. mn/v/rms square is equal to this 3 if you multiply to the left hand side, 3pv. So mn/v/rms square can't be substituted as 3 times pv. देख ले the above equation. Look into this equation. Can't we? Yes. So kinetic energy will be equal to half mn/v/rms square will be equal to 3 times pv. So in the next page I'm going to write kinetic energy is equal to, right, 3 by 2 times pv. Kinetic energy of all the molecules, right? 3 by 2 times pv. देख ले mn/v/rms square we have substituted as 3 pv, by 2 will be there, thus we have 3 by 2 pv. हो गया बच्चा लोग, बात तो हो गया. Kinetic energy is 3 by 2 pv. आ गया ना समझ? Okay. Now we all know the ideal gas equation pv is equal to nRT. So for 1 mole if you consider, pv का value हो जाएगा, n will take 1 RT. So for 1 mole pv का value will be equal to RT. So kinetic energy inside the bracket for 1 mole will be equal to 3 by 2 pv. We can substitute as RT and thus we have derived. हो गया हमारा derivation. हो गया तो हो गया, derivation हो गया, समझ तो आ गया. बता दे बच्चा लोग, आ गया तो आ गया. ऐसा the concept clear सबको समझ में आ गया. We have done 2 beautiful derivation ऐसे, even without you guys knowing we have completed the derivation. Okay, जल्दी बता, इधर तक clear है? Have you all noted? Okay, note किया ना? Yes, smart girl Shreya, clear and understood. Very good. Abhijit, Alpha, everyone. जय बोलो, चलो जय बोलो. Sir, lame joke please, lame joke. Lame joke नहीं है because मैं तो lime नहीं पिया है. अरे बहुत सारा lame हो गया वो. Okay, so kinetic energy for 1 mole. अरे देख ले. Okay, we have completed है ना. देख ले, listen, understand this so that you can do any problem related to this. Kinetic energy of 1 mole is 3 by 2 RT. एक मोल ले लिया तो kinetic energy is 3 by 2 RT. 1 mole मतलब, right, 6.022 into 10 power 23 molecules, right? In 1 mole, right, 6.022 into 10 power 23 molecules are there, or Avogadro number of particles are there. So for 6.022 into 10 power 23 molecules, kinetic energy is 3 by 2 RT. So tell me, what will be the kinetic energy for 1 single molecule? That is equal to total kinetic energy for Avogadro number, that is 3 by 2 RT, the whole divided by 6.022 into 10 power 23, which is said as Na, Avogadro number. We know R का value क्या है? 8.314. What is Avogadro number? 6.022 into 10 power 23. So R by Na will be equal to 8.314 by 6.022 into 10 power 23. We will get another value as 1.38 into 10 power minus 23. And this R by Na, we call it as Kb, or Boltzmann constant. Very, very important, because the conversion of R to Kb is very relevant in doing questions from this part. Okay, so universal gas constant by Avogadro number will give you another constant, which is Boltzmann constant, with a value of 1.38 into 10 power minus 23. So 3 by 2 R by Na is Kb into T. So this is the kinetic energy of one single molecule. For Avogadro number, the kinetic energy is 3 by 2 RT, मतलब for 1 mole. इधर तक समझ में आ गया तो any questions you can do, है ना? आ गया ना समझ इधर तक? सुमित, श्रेया, अल्फा, सपना, अरे क्लियर है तो गिव मी ए छोटू स्माइल दे दे. ओके, सो हाउ मेनी ऑफ यू आर रेडी फॉर डूइंग द न्यूमेरिकल्स? कौन रेडी है? हु ऑल आर रेडी फॉर डूइंग द न्यूमेरिकल्स? जल्दी बता. ओके हाँ बिल्कुल, मैं तो परफॉर्मर बन जाऊंगा एक दिन तो जरूर. कल है ना नेक्स्ट क्लास पे, मतलब थर्सडे है ना हमारा क्लास, जरूर गाऊंगा. अरे आई sang on Friday only. ओके ठीक है, सब रेडी है तो कर ले. अरे भूमिका रिपीट कर ले. अरे आस्क मी व्हाट इज योर डाउट, है ना? पूछ ले मुझसे डाउट क्या है. ऑब्वियसली आई विल बी एक्सप्लेनिंग यू आपका डाउट. अरे प्लीज एंटायरली रिपीट करना. आई वाज एक्सप्लेनिंग फॉर द पास्ट 1 hour, सो ऐसे हाउ कैन आई रिपीट द एंटायर 1 hour ऑफ कॉन्सेप्ट? न्यूमेरिकल करके ही जाता हूं तो कर ले. रीड द क्वेश्चन प्रॉपर्ली. यू कैन डू दिस प्रॉब्लम विद इन 1 or 2 seconds ऐसे, लेकिन दे 15 seconds. ओके ऐसे कर सकता है. यू ऑल कैन डू दिस प्रॉब्लम ऐसे विद इन छोटू अमाउंट ऑफ टाइम. एनीवन? Friday नहीं, Thursday. Okay, Preeti. Anyone with the correct answer? I didn't get the correct answer from anyone. किसी से भी नहीं मिला. One is to 16. Option C. अरे you don't need any time for doing this. अरे देख ले, what was the formula for kinetic energy, right? For one single molecule, per molecule if I take, what is the kinetic energy? That is equal to 3 by 2 Kb into T. Just now we have discussed 3 by 2 is a constant, Kb is a constant, and here in this case the oxygen and the hydrogen is at the same temperature, 27 degrees Celsius. Obviously when we use it in the formula, have to convert this into Kelvin scale. That is understood, right? But here both of them have the same temperature मेरा बच्चा लोग. So obviously kinetic energy will be same. So उसका ratio क्या होता है? 1:1. Option B. देख ले कितना simple है. अरे I told you seconds में मिल जाएगा आप लोगों को आंसर. Yes, Shreya, Pardeep, the option B is correct. Okay, got it? Sapna, yes, the option B is correct here. Okay, this is kinetic energy per molecule. I don't know from where you are telling, for one single molecule, not for the entire mixture we are talking. For one single molecule if you take of oxygen and hydrogen, kinetic energy same हो जाएगा. Okay, because there is a B part also for this question, right? That is confusing. Okay, next. अगला क्वेश्चन इज ऑल्सो बहुत बड़ा, बट आंसर तो ऐसे ही मिल जाएगा. Anyone? Go through the question here. Last 10 more seconds to answer. Anyone? Okay, everyone is going with the option C here. Arey bachcha, look, this is option A. Okay, I think, is this option C according to you? Is this option C? फिर तो सही है. If you are going with this as the option C, सही है. Both the options A and B are correct, or both the statements A and B are correct. I'll tell you, देख ले. A gas mixture consists of molecules A, B, C, D with their molecular masses in this ratio. Okay, fine. Two statements are drawn. Average kinetic energy of four types of gases in the mixture are in the ratio EA, EB, EC, ED. Yes, this is a gas mixture, right? A, B, C, D gases are mixed together, and if they are mixed, all of them will be having the same temperature. A, B, C, D has the same temperature, and if the temperature is same, the kinetic energy to same ही हो जाएगा for a molecule. So the statement A is correct. Yes or no? Yes. Second statement talks about Rms speed of molecules of the four types are in the order. Okay, that you need to explain. We know kinetic energy of one single molecule is 3 by 2 kb into T. Question is right now not about kinetic energy, about Rms velocity. How to do this? Kinetic energy of one single molecule is equal to half. Direct formula, mass of one single molecule divided into Vrms, the whole square is equal to 3 by 2 kbt. 2 cancel kare, Vrms square is equal to 3 kbt divided by mass of one single molecule. Matlab, Rms velocity is inversely proportional. The square of Rms velocity is inversely proportional to mass. So the one which has bahut bada mass will be having chotu velocity. Dekh le, which one has the bahut bada mass? A. So it will be having the chotu velocity. Yes, correct. Then the next mass, then the next chotu mass will be having the next higher velocity because they are inversely proportional. And the order goes like A will be least, the greater will be B, then for C, and the final greatest or the largest will be for D. Are the concept getting in your head? Is the concept getting in your head? Everyone जल्दी बता दे बोल दे हाँ सर बिल्कुल अच्छे से समझ में आ रहा है. Right, all the concepts are going directly into our head. No issues at all, है ना? कोई भी problem नहीं है. Yes रिद्धि जी हाँ yes. Okay ठीक है. अगला क्वेश्चन है ना? हाँ सर बिल्कुल दे. Don't make a mistake here. Okay, मेरा राइटिंग इतना छोटू है. ठीक है, let me see. इतना छोटू है तो थोड़ा सा छोटू है. ठीक है. The pressure exerted by an ideal gas is dash mean kinetic energy of translation per unit volume of gas. जल्दी. No, everything is perfect bouncing off because we aren't in such a mood to study this much without a नन्नू break, sir. अरे नन्नू break चाहिए. ठीक है, बोल तो सकता है आप लोगों को, है ना? Everyone is going with the option of A is most option and B is another option. ठीक है. Eye pain, cornea is paining. Okay, 5 more minutes. Okay, एक और क्वेश्चन करेंगे इसके बाद. This I'll explain. Right? Question is to find out the relationship between pressure and the kinetic energy per unit volume. Okay. देख, we know that the kinetic energy for 1 mole, 1 mole का kinetic energy is given as 3 by 2 RT. One single molecule it is kBT, for 1 mole it is RT. Okay. Now we already know the formula that PV is equal to nRT. And for 1 mole PV का value RT होता है. है ना? Okay, for 1 mole N is equal to 1, ठीक है, and PV will be equal to RT. So RT we can substitute it as क्या? PV, that is equal to kinetic energy. Now just rearrange, हो गया. This 3 by 2 will go to the left hand side as 2 by 3 kinetic energy. This volume I'm going to take it to the down. This is equal to P. So pressure is equal to 2 by 3 times mean kinetic energy per unit volume. So it's not 3 by 2, it's 2 by 3. Ulta. Ulta hai, ulta. Okay. Clear hai na? Ulta ho gaya. Question, so I think everyone was fooled with this question because everyone usually go with 3 by 2. लेकिन उल्टा पूछ लिया था. Okay, एक last question. Everyone is like, sir, हमारा आंख तो दर्द हो रहे sir. ठीक है? So one last question is what we are going to do right now, and after that, everyone is free. Go and have an amazing lunch. I'll also go and have a beautiful lunch out there. Very simple question this is. Okay, after this we're gonna wind up today's class. So everyone with full energy, by using your full energy here, give me the answer within 20 seconds. Which one? Everyone is going for the option D. Nah. Answer is not option D मेरे बच्चा लोग. Option वो तो नहीं है. A. Okay, so the correct option is 1.33 मेरा बच्चा लोग. I'll tell you कैसे. It's very simple actually. A flask contains argon and chlorine in the ratio of 2:1 by mass. The temperature of the mixture is 27 degrees Celsius. Obtain the ratio of RMS speed of the molecules of the two gases. How to find? I'll just tell you. We already know the kinetic energy of one single molecule is 3 by 2 kb into T. Okay, and the kinetic energy can be written as half m Vrms square is equal to 3 by 2 kb into T. Okay, half cancels, so Vrms is equal to, okay, this m will come to the left hand side, so this 3 kb T the whole divided by mass with a root, है ना? This is a formula for RMS velocity, 3 kb T divided by m. Question, what was it? Once again, obtain the ratio of RMS speed of argon and chlorine. मतलब we need to find out the ratio of RMS velocity of argon to RMS velocity of chlorine. For this, just need to get the formula of the RMS. What is it? 3 kBT by m. Array, both of them are at the same temperature of 27 degrees Celsius, right? So temperature same है, kb same है, ये 3 तो obviously constant, वो तो same है. So Vrms is inversely proportional to root of mass. इतना ही है. You only have to do this much. If you know this much, हो गया. So Vrms of argon to Vrms of chlorine inversely proportional to the root of mass of chlorine to mass of argon. अरे inverse आ जाएगा. Argon by chlorine will be equal to chlorine by argon with the root. आ गया. Now just substitute the value of masses here and get the answer. Mass of chlorine कितना है? अरे what is mass of one single molecule of chlorine? 70.9. ठीक है. Substitute कर ले. 70.9 हो गया. What is mass of argon given? 39.9. 39.9. Root कर ले. You will get the answer as 1.33. And that's our answer. Is it clear? बता दे जल्दी बता दे जल्दी बता दे. I was taking Mendy on this Friday. आप कहाँ थे शान? Good night Sumit. अरे everyone is so tired it seems, right? हो गया हमारा. And that was the last question and this is done. And yes, tell me, class कैसे थे? Have you all enjoyed? Wasn't long yet calculative. Todu 70 by 39.9. We have to say that it is almost 1.8 something, or and taking the root it will be 1.33. Yes. Yes, this was the last question. ठीक है, happy? अरे इतना boring हो गया सब. Everyone is like, sir, please tell us. ये तो बहुत last question है. Oh, not tired, ice burn. Oh, itna everyone. Is it only Miara is facing this ice burn, or everyone? Is everyone having this issue? अरे आज तो नहीं सुने था. Okay, I'll sing a song on Thursday. ठीक है. Okay. Now let me tell you, chalo, kinetic theory of gases ka. If you want to do more problems, come and join tomorrow's class. Okay. Tomorrow we have a special class at 4:30 on the Unacademy app. It is completely free. Okay. Special classes are free. Those who don't know, this is also free. How to join? A link is being pinned on top of the screen. Click on it and you can be a part of this class completely for free. Just use the code of AMB10. Okay, they'll be asking for a referral code. Just put the code of AMB10. You can be a part of this class for free. You don't have to be an iconic subscriber. Plus subscriber kuch bhi nahi. Click on the above link which is given on the chat screen and you can be a part of the special class. ठीक है? The code is AMB10. Don't miss it. Very important. अरे अभी right now click on the link and you can enroll for the course. अभी क्या अभी तुरंत चाहिए सब. And one more link you can find, that is the link to my Unacademy profile. You can click on it and you can follow me so that whenever any free special classes happens, it will be giving you notifications. ठीक है? So as you all know, Unlock 20 is happening. Matlab, if you make the subscription right now and if you are ready to use my code of AMB10, 20% discount is what you are going to get. This offer is only till tomorrow. Don't miss it. It was really amazing session, Jia. Thank you so much. Okay, and those who don't know, Unacademy Prodigy program is happening. Okay, it happens 29th ka ho gaya. Next is on Feb 6. So this is an amazing way to get scholarship, 20 lakhs worth of scholarship for your colleges. Don't miss your chances. It is going to happen on Feb 6. For each classes schedule and time is given. And if you win the first rank, Apple का laptop मिल जाएगा, second and third rank Apple iPhone मिल जाएगा, 4 and 5 Apple iPad, and others will be given so many amazing gifts like this. So don't miss it. Right? This is next is going to happen on 6th, है ना? So be a part of it. Other batches is what you are seeing right now. So you all can be a part of this batches and start learning with the Unacademy family. Special class timetable I already have shared with you. Special classes are completely awesome because we have a real time, you can chat with us, right? Live chats is there, question tabs where you can ask your doubt and get it cleared. Live polls and a leaderboard which will make the session so much interactive and fun. So don't miss tomorrow's class. And those who haven't shown some love towards your bhaiya, this is your time. Move your cursor, click on the like button. Everyone, those who haven't shown some love, this is your time. Jaldi फटाफट कर ले. ठीक है, click on the like button. Do let me know that you have enjoyed. So, हो गया. We'll be meeting for the 11th class at 8 p.m. on Thursday with the third session of this particular chapter. Right? So, thank you so much. Nandri. Okay. Okay. So, thank you so much, everyone. Bye bye. Okay. Take care and enjoy your life. Bye bye.